In this part of chemistry, we are going to talk about bases and acids. We can understand what are acids and what are bases, and what are acidic solutions, what are basic solutions, and what is water ionization or self-ionization of water. And we can understand what is monoprotic or types of acids, which is monoprotic, diprotic, polyprotic. Okay, the first point now, what is acids and what is bases? Okay, acid or bases, both of them, they are chemical substances. Okay, they are chemical substances, but they behave, when they dissolve in water, they behave in specific or in different ways. How? Okay, base, it has in general, bases, they have a bitter taste. Okay, what about acids? They have a sour taste. They have a sour taste. Okay, this is related to how they are tasted. Okay, what about how we test that this chemical substance is an acid or a base? How will we know? Okay, you have something called litmus paper. And litmus paper, by the way, if the solution is acidic, it turns or it changes this litmus paper into red if it is acidic solution. Okay, what about if it is basic solution? It changes this litmus paper into blue. So we link that like acidic, that means we link it with red, and blue with base, B with B. Good. Third point, we can understand what is self-ionization of water. Okay, we know that water is H2O. Good. Water is H2O. And this is just one molecule of water, H2O. Every molecule, it consists of 2 hydrogen atoms and 1 oxygen atom. Okay, this is just as one molecule. Okay, in water, we have too many billions of molecules of water. Self-ionization of water. Self-ionization of water, it means when one molecule of water donates 1 hydrogen atom to a neighboring water molecule. So look this one here now, which is H2O. When it dissolves, it's gonna be H positive and OH negative. Good. Now it will, this one now, I'm talking about this water molecule, it will donate this hydrogen atom to the left or to the neighboring molecule of water. So this one now will become what? This one now will become what? It's going to be H, but how many H now it will have? It will have 3 H and O, but here what? Positive. And this is called now hydronium. And this one here is OH. So that means self-ionization now in water, we will get H positive and OH what? Negative. This one is called hydrogen ion or proton, and this one is called what? Hydroxide. So self-ionization of water, it gives you same number of H positive and what? And OH negative. So that means same number of hydrogen ion and hydroxide ions in self-ionization of water. And just a small portion of molecules that they do that in pure water, a small percentage. That means they cannot be counted compared to the huge amount of molecules that they don't. So this is now what is called self-ionization of water. And we come back to it. We're gonna come back now to it. We're gonna come back to it in another point. We'll be back to it. Okay, we'll go now into another point now, which is the main point of the lesson of today, which is the definitions of acids and bases. What are the definitions? So, and who defined them? Who gave these definitions? Okay, you have 3 definitions for acids and bases. Okay, definition number 1, It is for Arrhenius. It is for Arrhenius. He is a scientist. Okay, what did he define? Bases and what? And acids. We're going to start by acids. Then here what? Base. Okay, what is Arrhenius' definition? Okay, Arrhenius now he gave a definition for acids and bases. What did he say? Arrhenius said an acid is a chemical substance that it has hydrogen. It has hydrogen atom and it donates hydrogen ion. Thank you. This is an acid based on the definition of Arrhenius. Okay, Arrhenius, thank you. What's now the definition of base? He said a base is a chemical substance that it has hydroxide and it donates what? Hydroxide as well. So that means it has OH and it donates OH in reactions. And acid, it has H and it donates H in reactions. Keep that in mind. Okay, we're going to ask now a question. Okay, Arrhenius, thank you for your definition, but we'll ask a question. Is your definition applicable for all bases and acids? Can you apply it for all bases and acids and it works with all of them? No. Why? Because now we have an exception. Okay, we have, for example, here NH3. And H3 now, based on Arrhenius' definition. Is this one now a base or an acid? It doesn't donate H in reactions, and in this case it's not acid, and it doesn't have OH, and in this case it's not a base based on Arrhenius' definition. But in real, NH3 is a base. So that means Arrhenius has a weakness point or a negative point that its definition regarding the base is not broad enough to include all the bases. That means we have bases, in reality, we have bases that they don't have OH, but they are classified bases. So that means the definition that is related to base for Arrhenius is not that general, or it doesn't cover all the bases. Okay, you have examples for acids, like here, for example, you have HCl. Here now this is an acid because it has, as you see, H, and when it reacts, by the way, it donates the H. So that means this is Arrhenius acid and it is an acid. And here you have NaOH. As you see, it has OH here, and in reactions it donates the OH. So that means in this case, we call this one a base, and this one is what? Also acid. So for most and for many of acids and bases, Arrhenius' definition is okay, and it covers too many of them. Okay, since this definition is not applicable for all the bases, that means we need now a new definition. Okay, what is the second definition now? The second definition is called Bronsted-Lowry. Bronsted what? Lowry definition. Okay, why do you call it Bronsted-Lowry? Because it was named after two scientists who gave this definition. And they were in two different countries, but since they gave the definition at the same time and nobody knows about the other one, so we named this definition after these two scientists, which is what? Bronsted-Lowry definition. Okay, what is their definition now? Their definition for acids, they said acids is H donor. So that means an acid is just a chemical substance that can donate, that is a donor for hydrogen ion. For hydrogen what? Ion. And hydrogen ion, which is H positive, hydrogen ion, and as we know, hydrogen, it has one electron and one proton. So if it loses the electron, what will be left there is only the proton. So that means it is called hydrogen ion, or it is called proton, because it has only one proton left. So acid now, based on Bronsted-Lowry definition, it is a chemical substance that is hydrogen ion donor or a proton donor. Okay, what about a base? A base is the hydrogen atom acceptor. So this one here is a donor, and here is what? Acceptor. Thank you. This is what? Accept. Good. So now we have acceptor, and we have what? Donor for the hydrogen ion. For only what? The hydrogen ion. So here now in Bronsted-Lowry, did they mention OH? Did they mention hydroxide? No. So that means they gave a definition that is based only on accepting or donating hydrogen ion. In this case now, if we go to this one here, NH3. NH3 now, based in Bronsted-Lowry, it is a base. That means now this definition now of Bronsted-Lowry, it includes the NH3. Okay, how is the NH3 is a base based on Bronsted-Lowry? Okay, we're gonna take this example. If we have NH3 here, and here when it is with water, H2O, what will happen? As we know, water will be ionized into H positive and OH what? OH negative. Good. And here in this case now, the H here will go to NH3. Then NH3, which is ammonia, it will be transformed into what? It will be NH4 positive. Okay, good. Then what is left? What is left here is what? OH what? Negative. So as you see here now, which one of these two parts was the donor of the hydrogen ion? It was water. So water in this case, based on Bronsted-Lowry, it is an acid. In this case, it is an acid since it is the donor of the H. You see, it's the donor of the H. Okay, which one of them that accepted the H? So NH3, as you see, it accepted what? It accepted the hydrogen ion. So in this case, NH3 is a base. Why? Because it is the acceptor. So that means this one now is a base. As you see, classified, this one is a base, and this one is what? An acid. An acid. So how this acceptance has achieved, we can explain it also with the third definition. But we need now to understand one more idea on such a reaction. Look, NH3 now, NH3 here, which is ammonia now, it is a base based on Bronsted-Lowry definition because it accepted the hydrogen. And here now, H2O is an acid because it is the donor of the H. Thank you. This is before. On the left of the reaction, what? Equation. Now on the right of the equation, what happens? NH3 accepted, as you know, the H, and it becomes NH4. Okay, NH3, what it was? It was base. You see, it was base. And in this case, what is gonna be named? It's gonna be known now an acid. It's gonna be named an acid. But what type of acid now? We call it conjugate acid. So what is conjugate acid? What is conjugate what? Acid. So look here now, how can we draw these ones? We write this one as base plus acid gives me what? NH3 now is called conjugate acid. Okay, what about OH? It is called conjugate what? Base. What does that mean? Because now if we reverse the reaction, to the left, which one will become the donor of the H? Of course, ammonium, which is NH4 here, will be the donor of the what? Of the H if we reverse the reaction. If the reaction goes to the left. When it becomes now the donor of the H, that means it is an acid now. But is it the original acid? No, we call it conjugate acid because initially it was base. So here the base, after it accepts the hydrogen ion, it will become what? Conjugate acid. Okay, what about this one now, which is water? As you see, it is an acid here because it is the donor of the H. After it donated the H, it becomes what? Conjugate base, which is OH. Because now the OH, if the reaction is reversed to the left side, the OH now will become the acceptor of the hydrogen. Will become the acceptor of the hydrogen. So in this case, it is called what? The base. I hope that is clear. So look, base and Bronsted-Lowry, we need to understand now just one important sentence in order to memorize. Bronsted-Lowry named the acid as the donor, as the generous side. Acid is the generous side for what? For positivity. What do you mean for positivity? That means for positive ion, for the ion of the hydrogen, which is what? Positive, which is the proton. So that means Bronsted-Lowry, memorize that in your mind. They are two people, a team, and they named acid, or they described the acid as a generous side of positivity, which it gives what? The proton of hydrogen. Good. We'll go now into the third definition. We'll go into the third now definition. What is the third definition here? And as we said, we have three definitions for what? For bases and acids. Okay. Third definition is called Lewis. It's called what? Lewis. So this Lewis definition now. Lewis definition, by the way, it is named after a scientist. His name is Lewis. And he gave this definition. Look what he defined. He defined now the opposite. For acid, he said it is acceptor. So acid, it is what? For acid, it is two electrons or a pair of electrons. A pair of electrons. Good. A pair of electrons. Here, acceptor. Keep that in mind. This is what? Acceptor. This is for acid. Okay, what about for base? It is same thing, a pair of electrons, but here what? Donor. So how can now, in order to memorize, look, for Bronsted-Lowry, we said, they said who was the generous side? For Bronsted-Lowry, they said the generous side is the acid. And it is a generous with what? With positivity, with positive ion. But here now for Lewis, he said who is the generous side? Is the base. The generous side is what? Is the base. Good. Is it generous by what? By negativity. Keep it in mind now. So the base, when it is generous, it is generous with negativity. And this is Lewis. And the acid, when it is generous with positivity, with proton. And in this case, it is Bronsted-Lowry definition. Okay, how does that happen? So look, Lewis now said that an acid is the acceptor or a chemical substance that accepts a pair of electrons. A pair of electrons, that means two electrons. While the base is the chemical substance that is the donor that donates a pair of electrons. Okay, we'll take example and we'll take the same example here. We'll see if it works with this definition or no. That means, will the NH3 work here or no? Okay, we're going to take it. NH3, this one now, which is NH3, we know that the N is the nitrogen. This is nitrogen. And nitrogen, we know it is on the 15th group, on the periodic table. Since it is in the 15th group in the periodic table, that means it has 5 electrons around it. In the valence electrons, it has 5. So that means 1, 2, 3, 4, 5 electrons. And these now 5 electrons that are around the nitrogen, they'll give the nitrogen a chance to make covalent bonds. So the nitrogen now will make covalent bond with what? With the hydrogen, because it has 3 hydrogens. These 3 hydrogens, one will be here, and one will be here, for example, and one will be what? Will be here. Good. One will be also here. Good. And the hydrogen, as we know, it has 1 valence electrons. 1 valence electrons. So this hydrogen now, it has 1 valence electrons, and this one has 1, and this one has 1. So in this case now, these 2 will make a bond. And these 2 electrons, they'll make a bond, and these 2 electrons will make a bond. So as you see now, for NH3, which is ammonia, it has 3 bonds around the central atom, which is nitrogen, and it's still, as you see, it still has 1 pair of electrons free. 1 pair of electrons what? Free. So in this case now, for this reaction, as we said, when the hydrogen now, as we said, is in the reaction with what? With H2O. With H2O. And when we said H2O, it's going to be H positive and OH what? Negative. Get the H now here, it will go where? It will go here. You see? It will go in this part. And this hydrogen now, when it goes to the other side of the nitrogen, the coming hydrogen now has no electrons. It has only 1 proton. And in order to make a covalent bond with the nitrogen, it has to have 2 electrons. Okay, who will give it these 2 electrons? This nitrogen. So these 2 electrons now will be given for this hydrogen here, and they make with it what? A covalent bond. And in this case now, the nitrogen will be surrounded by 4 hydrogens, and it becomes the central. So in this case now, NH3, which is ammonia now, it is the donor. But the donor of what? The donor of a pair of electrons that they were free around the central atom, which is nitrogen. So it donates these. Okay, who or which part accepted this pair of electrons? The hydrogen. And the hydrogen came from where? From water. So water is the acceptor here. So since it is the acceptor of the pair of electrons, so that means in this case, water is the acid, because it is what? Acceptor. Acceptor of what? Of 2 electrons. Of 2 electrons, just a pair of electrons. And which side was the donor of these 2 electrons? As you see, NH3 was the donor of these 2 electrons. That means it is here the base. So based on Lewis definition, NH3 is also a base because it was the donor of a pair of electrons. And based on Bronsted-Lowry, NH3 is also a base since it is the acceptor of what? Of H positive, of the ion, of the proton. So that means NH3, if we classify it based on Bronsted-Lowry definition, it is an acceptor of what? Of a proton that came from water. Good. And if we classify it based on Lewis definition, it is a donor. It is a donor. It is a generous in this case. It is a generous of what? Of negativity of the 2 electrons, of a pair of electrons. Then in this case, it is what? A base. So in both definitions, it is a base, which is Bronsted-Lowry definition and Lewis definition. But Arrhenius definition now has no classification for NH3 because it's not included in its definition. So here now we'll get NH4. And we understand NH4, that means 4 hydrogens around the nitrogen atom. And here we have something here called positive. We write here positive. Why we write positive? Because the charge overall the molecule or a compound. It indicates which one is more protons or electrons. That means in this case, NH4, which is ammonium, in this case, it has protons more than electrons. So that means it is positive. But it's still the same covalent bond for the nitrogen and the surrounded hydrogens. And here we have what? OH negative. So you understand now what is Lewis bases, what is Lewis acids, right? And you understand that NH3 is a base, and also here, this one is acid. Okay, H2O, which is water. In general, is it base or acid? Okay, water is called amphoteric substance. Water is called amphoteric substance. And this substance, and any substance is called amphoteric, that means it has two phases. How two phases? That means with acids, it's gonna behave like a base. And if it is with a base, it will behave like an acid. This is amphoteric substance, and water is a amphoteric substance. Good. So we have like PCl3, and you have BCl3. These ones, this one is acid, and this one is what? Is a base, based on what? On Lewis structure. So you have several compounds, 3 or 4. You have to memorize them for Lewis and acids of what? Of Lewis. Acids and bases. Okay, if we go now to types of acids, we know that HCl is hydrochloric acid. Since it has hydrogen and it donates the hydrogen based in Arrhenius, and since it is the donor of H, since it is based in Brunstad-Lowry, and since it is the acceptor of a pair of electrons based on Lewis, so that means this one now in all, that means this one is an acid. Good. But this one now, when it is an acid based in Brunstad-Lowry, when it donates hydrogen atoms, how many hydrogen atoms can it donate? It has only one hydrogen atom. So that means it will donate only one hydrogen, right? So in this case, we call it monoprotic acid. Good. What about here? HCOOH, which is methanoic acid. Methanoic acid also, if it donates, when it donates only one hydrogen. So it becomes like this here, as HCOO negative, and here H what? Positive. So it donates one hydrogen. Also, this one is monoprotic. Also for ethanoic, which is CH3COOH. This one now is also ethanoic. When it donates only this electron. So that means these ones are monoprotic. Why you call them monoprotic? Because they have only one ionizable hydrogen atom. One ionizable hydrogen atom. That means they can donate only one hydrogen. So these ones we call them what? Monoprotic. Okay, what about diprotic? What about what? Diprotic. Okay, diprotic acids is like H2SO4, which is sulfuric acid. Which is what? Sulfuric acid. This one now, when it donates, it can donate two hydrogen, not just one. Okay, when it donates one, it will be transformed to be HSO4 negative. Okay, this is for the first step, when it donates one hydrogen. Also, it can donate one more hydrogen. Here it has two hydrogens. When it donates one, it will become like this. Okay, if it donates now the second hydrogen, it will become SO4, and here's what? 2 negative. Okay, that means H2SO4, we call it what? Diprotic, because it can donate 2 hydrogens, so we call it di. Okay, what about if we have another one like H3PO4? PO4. In this case now, what do we call this one now? We call it what? Tri. Why we call it tri? Triprotic. Okay, we call it triprotic because it can donate 3 hydrogens. 3 hydrogens. So we have mono, and these ones are called polyprotic. Polyprotic, that means they have more than one ionizable hydrogen atom, whether they are di or tri or other ones. Good. So you understand now types of acids based on number of ionizable hydrogen atoms. Okay, we'll go back now to the point that we said earlier. We're going to come back to it, which is self-ionization of water. Self-ionization of water. Okay, water in general, when it is ionized, it produces, as we said, OH negative and H positive. Good. And each of them now, each of them will have a concentration. And when you understand what is a concentration, means how many of these ones are inside the solution, how many OH ions inside the solution, and how many H positive in the solution. This is the concentration. So this one is the concentration of this one now times the concentration of this one here. It calls what? The constant or water ionization constant. Water ionization constant, it equals the multiplication of concentration of OH times the concentration of H, and it gives you always a constant number that is what? 10 to the power of negative 14, and keep that in mind. Okay, if these ones now, if these ones here in nature, in neutral solutions, by the way, the number of hydroxide ions equals the hydrogen ions. If they are the same, we call it neutral solution. Neutral solution. But that means if they are the same, this one will be 10 power negative 7, and this one will be 10 power negative 7. So when you multiply them now, you will get 10 to the power of negative 14, because when we multiply the powers, we add them. So you get 10 to the power of negative 14. Good. This is now for neutral solutions. Okay, now, what about if it is... So you understand now, in neutral solutions, concentration of OH and concentration of H are the same. Good. What about if it is now not neutral solution, if it is acidic solution? Acidic solution or what? Or basic solution. Good. If it is acidic solution now, if it is acidic solution, the concentration, we said acidic based on acid, and acid we know it is the donor of H, that means it has more H, so the concentration of H is greater than the concentration of what? Of OH. In this case, if in a solution the concentration of hydrogen ion is greater than the concentration of OH ion, this one is acidic solution. Okay, what about basic solution? It's exactly the opposite. So that means, in this case, OH negative, the concentration is greater than what? Than H. So in this case, the concentration of OH is greater than the H. So we call it basic solution. Good. And now, the multiplication in general, the concentration, as we said, of OH multiplied by the concentration of H will give you always a constant that is 10 to the power of negative 14, and keep it in mind. So even if one is more, one is less. Look, for example, here now, the concentration of here, the concentration of this one is 10 power negative 3. What will be the concentration of H? If the concentration of OH is 10 to the power of negative 3. And as we know, when we multiply these concentrations, they have to give us what? 10 to the power of negative 14. So that means this one has to be 10 power what? 10 power what? 10 power negative 11. 10 power negative 11. So that means if we multiply now 10 power 3 times 10 to the power of negative 11, we'll get what? 10 to the power of negative 14. So as you see now, okay, now which one is more, okay, in this one now, in this solution now, is it acidic or base? Okay, this number, it means concentration. And now which number is greater, 10 power negative 3 or 10 power negative 11? Which one is greater? Look, the higher, like if it is negative power, the higher the number next to the negative, the less the value. So that means now, in this case, 10 to the power of negative 3 is greater than 10 to the power of negative 11. That means OH has more concentration than H. In this case, this one is called what? Basic solution. Basic solution. And it's the opposite. So that means when we multiply the concentration of OH and H, it will give us a number that is constant, which is 10 to the power of negative 14. Good. And here now the concentration is 10 to the power of a number. Good. This number now here, if it is a power, a negative number, this number now, if it is this number alone, if it is less than 7, that means it is greater concentration. If it is greater than 7, without the negative I'm talking, so that means in this case, it's gonna be less. If it is greater than 7, that means the concentration is less. And now we understand, based on this number now, based on the concentration, now, we can understand, is it basic or acidic solution? Okay, again, take example. Just if there is a solution and the concentration of H is 10 to the power of negative 9. Get only this idea. The question now will come to you, is this one acidic or basic solution? Good. So here now, if they give you now H, which is 10 to the power negative, that means the OH negative, what will be its concentration? You have to remember that with this number now that I write it here, they have to give you what? Negative 14. So here negative 9, so here will be negative 5, because now when I add negative 5 with negative 9, they give me negative what? 14. So that means if the concentration of the hydrogen ion is 10 to the power of negative 9, that means the concentration of OH will be 10 to the power of negative 5. Now which one is greater? 10 to the power of negative 5 or 10 to the power of negative 9? Which one is greater? Since the power is negative, so that means this one is greater than this one. So that means this one is greater than what? Than 10 to the power of negative 9. Since this one is greater and it is for the OH, so this solution is basic because the OH has higher concentration than what? Than an H. And I hope that is clear. And just now I need to add you something here now. This one now is called the concentration. This called is the concentration. But we have something called pH. What is pH? pH is equals negative log the concentration of H. Okay, what does that mean? Look here now. For this example now, if we apply it, what will be the pH? The pH now will equals negative log of H. What is H now? Here the concentration. It is what? 10 to the power of negative 9. Thank you. What's next? Okay, log. If the base is not mentioned, that means the base of the log is 10. The base of the log is what? 10. And here, log 10, if the base is 10 and here is 10, so that means this one just will be written in terms of its power only. So that means here the pH will become negative here, then times negative what? 9. So it equals what? 9. So the pH is 9. Okay, what is pH now? The pH now, it's an indicator to make it easier for you. How? So if I tell you now, what is this solution is acidic or basic based on concentration, you may find it harder to understand it. 10 power negative 9, power negative 9. So in this case now, I'm gonna cancel you the power, and I'm gonna cancel the base, and I'm gonna cancel the negative, okay? And I give you a number easier, just a number itself, which is 9, which is just the number that is in the power here alone without the base and without the negative. Okay, for the pH. Okay, pH now, which is related to the concentration of hydrogen. For pH now, if the pH is less than 7, that means the power now, regardless of it is negative, is less than 7. That means the concentration of H is higher, so that means this one is what? Acid. Good. What about if the pH now is greater than 7? So that means this is what? Base. This is base. And if the pH is much smaller than 7, that means it's closer to 1. That means this is a strong acid. If it is greater than 7, closer to 14, that means this is a strong base. This is now for the H. Now this is for the H. Okay, what about the pH, the POH? The POH here, it's the opposite. The POH, if it is less than 7, that means this one is a base. Okay, if the POH is greater than 7, that means this is what? An acid. And same thing now here. If this POH is less than 7, close to the 1, that means this is a strong base. And POH plus pH, they'll give you all those 14. So that means pH plus POH, they give you what? They give you what? They give you 14. So you can memorize one of them, and in terms of this one, you understand the other one. That means if I use I memorize this one now, POH will be the opposite. So if I tell you now pH, if I tell you just this example here, I'm going to write it in this place. If I tell you pH equals 4. Now find me the following. Find me the following. Find me the POH. Good. Number 1. Number 2, tell me, is this one acidic or basic solution? Okay, this is now number 2. And number 3, tell me what is the concentration of the H and the concentration of OH. Good. Since now pH is 4 and pH plus POH will be 14, so that means this one will be what? Will be 10, because this one they have to be what? P of H and P of OH, they have to give me 14. So that means this one has to be 10. And since here, as you see, pH is 4. Okay, pH 4. Is this one satisfied? pH is 4. That means, is it less than 7? Yes. So that means this one is acidic solution. Good. Now, what is now the concentration of H? The concentration now of H will be 10 to the power of negative what? Negative this number. You see 4. This is now pH. And what is now POH? POH will be what? Will complete this number to be what? Negative 14. So 10 to the power of negative what? Negative 10. So now we understand how to find pH, how to find POH, and what do they mean. Okay, last point, just it's a minor point, and we need to understand it just, which is anhydrate. Anhydrate. This one, for example, now CO2. What do I call this one now? I call it non-metal. Non-metal, because carbon is not metal. Carbon is not metal. So CO2, I call it what? Non-metal oxide. So this one, non-metal oxide. When it reacts with water, with H2O, it will give us what? It will give us what? It will give us an acid. It will give us an acid. So anhydrate, just we need to remember that for non-metal oxides, when they react with water, they give us what? They give us acid. Good. What about if I have metal oxides like NaO, like Na2O? Here now, when they react with water, keep it in mind, they give us here what? Base. They give it to us base. Just to try to remember that. This is for anhydrates. So we finished this part that is related to bases and acids, and you understand their definitions, their change of litmus paper, self-ionization of water, the ionization constant of water, what is pH and pOH, what's their sum, and what's the number related. Thank you so much. See you in other videos.